Hey guys, I'm Rowan the physicist, and I'm here with Holt, the assistant physicist, and today we are going to be proving something. It's kind of chemistry related, but also physics, about how water is polar. And Holty, do you know what polar is?
No.
Well, a polar molecule is when... oops, sorry, I thought I just spilled the water, I didn't. It's when a molecule has a slightly positive side and a slightly negative side. And Holt was just picking his nose. Okay, so, and opposites attract, Holty. So electrons, which are negative, are attracted to protons, which are positive. And electrons want to repel electrons because they're both negatives, and same with protons. So, a polar molecule is one if the side is slightly positive and slightly negative. So naturally, the positive side will want to attract other molecules negative side, and for polar molecules are attracted to each other. So, and hydrogen is a special kind because, sorry, I have a little note here, because they are very highly electrostatic. So when hydrogen are bonded with either nitrogen, oxygen, or fluorine, it'll be especially strong. It's a dipole. Yeah, so today we're going to be proving that, and you know how we're going to be proving that?
Proving it.
Well, we're going to be putting water on a coin, and we're going to see how it goes over the edge, because they want to stick together.
Yeah,
and then we're going to be showing you
it's 25 cents.
Yes, it is. And then we're going to be showing you something how I used to do when I used to take baths as a child. I always just do this cool little water thing in the bath, and I never knew why it worked until this year. So let's go. These are water molecules, H2Os, and then this is the intermolecular force between them, since the slightly negative oxygen is attracted to the slightly positive hydrogen. They're connecting, and there's so many H2O molecules all over. I'm just showing how an example. So they want to stick together. And now we're gonna move on to the experiment with the coin. Cue. So I just taught Holty that that finger thingy when you put it in, and then you know what I mean. And then you release it. You all know. Okay. So Holty, can you please put the water on the coin, please?
We're gonna spill it.
Just fine. Just make sure it's all on. Holty, maybe you can hold it so it's stable.
Oh yeah, spill it.
Okay, I'll just hold it with this end. Okay, I'll just hold it. Good. Oh, that was a lot. Maybe try a little bit less. And we can do drop it by drop it. Let me just try it. Okay. Drop a little tiny, good. I said tiny bit.
Yeah, that was.
Try a little tiny bit.
Okay, how about you just try it?
No, I believe in you.
No,
I believe in you. You're good. If we had a droplet thing, that would be good. Okay, anyway, it's fine. We'll just work with this. Okay, so maybe. Oh, it's not really working. Anyway, I'm just gonna show you. So I'm sure you've seen if you can do it before, or I just have a better idea. We didn't even have to do that. We could. And
Yeah.
more water. Can you hold it? Can you film, please? Can you take the straw out, please? Take the straw out. Thank you. Can you film me? Film this cup.
Hi guys.
Okay, Holty, are you filming this? Are you filming the cup?
Can I just? Yeah.
Okay, I might make a mess. I'll clean it up. I'm good. Okay.
Dad, she just spilled it.
Good.
She's spilling it.
No, I'm not. Look. Ooh, can you zoom in on the surface, Holty, please?
What does that mean?
I'm gonna just move the camera close towards the top of the cup. Make it this angle. No, hold it, Holty. I need you. Good. Okay. I'm gonna, as you can see.
Looks like glass.
Yeah. So
Is it glass?
the water is over. Holty, I don't think you're filming it.
Oh.
Okay.
Mm-hmm.
Look. Come close. Come close. Let me just see. Let me just see. Okay. You can see. Look, it's the water is coming over. Holty, I need this. You're good. Okay, Holty's putting it there. Look, you can see the water is coming over the edge of the cup. Look, it's over the edge. Oh my gosh, look how cool that is. Look. Holty, come here. Can't you see? Look, the water is over the cup. Isn't that so cool?
Is
Yeah,
it?
is.
Let me see.
Yeah, it is. there's a slight little bit. The water's over the cup. That's because.
That's
Well, I erased it.
molecules.
Yeah, I have a photo here. Look. They're attracting. This is like H. See, this is O and this is H. And then this is, if they're like attracting each other. Whoa, you're on my back. Can you please get off? We have another experiment to do. Holty, please. Can you get off my back? Oh my gosh.
Then I film.
Okay, film. Okay. Make sure it's not upside down. Okay.
It's upside down, okay.
No, it's not. Okay. Come here. I'll clean the mess up. Don't worry. Holty,
I just want to see what...
is it upside down now?
It goes the same way.
Guys, I know, but when people are watching it, okay, good. So can you come over here, please? Okay, come up and film this area, please. Holt, if you're being silly, look me. Holt. Okay, good. So, can you film this area, please? So, can you film over here, Holty? Good, good. So the water is filled. Okay. Well, I actually want you to be my little helper because I need to see what you feel. Okay. So you're going to. Are you looking at the cup?
Yes.
Okay. Let me hold it. I'll give it to you after. So you just fill it with water like this. Make sure it's filled with water. Don't just go like this. You have to make sure it's filled with water. Okay, Holty? Are you looking? Look. No.
Yes.
Okay. So make sure it's filled with water and then pull it up. And if you start to feel like it doesn't want to go anymore, tell me when and go very slowly.
No.
Okay, good. Stay there, please. So there's water in this cup, okay? And the water molecules in there want to stay close. They want to be with the water in here. So that's why he feels like a slight pull. They want to be together. So Holty, if you lift it up now, all the way up, water just falls because it wants it. Well, obviously gravity is putting it down, but it wants to stay in there. Isn't that cool? I used to do this all the time in the bath. When I have a little cup, I would just like go like this, and then I was just like, oh, so cool. But then when I just put it down like this, and then I ran up, it didn't really because there's no water in there, like, no pull. But now water in there, pull. Whoa, isn't that so cool?
It's like that, like so weird.
Yeah. So that's that. Okay, Holt. So did you learn anything special about water?
I learned about water.
What did you learn about it?
Water.
Did you learn that that water molecules want to be close to other water molecules?
Tiny bit.
Okay, tiny bit. Okay, and that is because water molecules are dipoles, which means they have a slightly positive end and a slightly negative end. And dipoles want to be close to other dipole molecules. And water is an especially strong one because hydrogen mixed with nitrogen, oxygen, or fluorine are very, 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 very strong. But all the intermolecular forces, which is a dipole force, something that I just told you, are weaker. Even the strongest one, the hydrogen one, is weaker than the intramolecular forces, which is what keeps the oxygen and the hydrogen together. What keeps the actual molecule together. Same with like other ones like carbon dioxide, CO2. Those are much stronger because if intermolecules, like the dipole that I just talked about, if those were strong, then everything would just be everywhere. Like there'd be nothing. Like mind equals blown, right, Holt?
What?
Okay, so, and I have some videos coming next. I have soon a video of me talking with my friend to non-physics teachers about physics questions, and I have a video about like part 2 of my catapult with like all the data and stuff. So look forward to that in the future.